Hello everybody. Okay, so in this final video here, we are going to be looking at solving inhomogeneous difference equations. So in the previous video, we were looking at homogeneous second order difference equations. In this video now, we are looking at inhomogeneous difference equations. So if you recall, a inhomogeneous difference equation is a difference equation that not only contains terms, like term values. For example, here, I have un plus 1 minus 3un minus 40un minus 1 equals 3 to the n. So I have like a function of n here. This is what makes it inhomogeneous. Over here in this one, right, the 8n plus 5 is what makes it inhomogeneous, right? Or even as simple as adding a constant term, that's what makes it inhomogeneous. So how do we solve inhomogeneous difference equations? Well, we do literally what we did before. We just have one extra step. So to find the solution to an inhomogeneous difference equation, we need to find the complementary solution, which is just solving the homogeneous part or finding a general solution for the homogeneous part of the difference equation, which is what we did in the last video. And the new thing is we need to find the particular solution, right? So that was what fits on the right-hand side of my equation. And then we add the two of them together. And then that is how we create our solution for inhomogeneous difference equation. So before we do that, we need to know what a particular solution is. So a particular solution is just a guess that matches the right-hand side of our equation. So it doesn't solve the whole equation, it just solves the part that makes it inhomogeneous. So we add it to the complementary solution to get the full answer. So if my right-hand side is just a constant term, we let un equal a. If it's a linear function, so 6n minus 7, we then let un equal an plus b. If it's a quadratic, we let un equal an squared plus bn plus c. And if it's exponential, for example, if it was like 3 times 7 to the n, well, the particular solution will just be a times 7 to the n. Right? So, how to solve a inhomogeneous equation? So you rearrange the equation so you get all of your term values to one side and then everything else to the right hand side. You solve the homogeneous equation. So that's just finding the general solution to a homogeneous equation that we did in the last video. We get the particular solution, right? So for example here, if my right-hand side was 3 to the n, my particular solution would be a to the 3n. Or if it was a linear function like kn plus c, my particular solution would be an plus b. And then we need to compute it for each term. So un is an plus b. That means un plus 1, so wherever I have an n, I'm putting in n plus 1. So it'd be a times n plus 1 plus b. And un plus 2 would be a times n plus 2 plus b. So wherever I have n, I'm putting in n plus 2. So we then sub it back into my original difference equation, and we're going to get an algebraic identity. All right. So let's have a look here first, because like I said, there's no point. No point me just talking about it. Let's do it. So solve the following difference equation. So I'm going to first look at the particular solution. So if we look here, everything's reordered. Stunning. Perfect. So I have un plus 2 minus 6 un plus 1 plus 9 un equals 8n plus 12, where u0 is equal to 6 and u1 is equal to 16. So my right-hand side is what makes it inhomogeneous. So I'm going to say step 1, right? Let un equal, so finding my particular solution now. So it's a linear equation, so un is going to be an plus b. So if un is equal to an plus b, un plus 1 is equal to a times n plus 1 plus b. And un plus 2 is going to be equal to a times n plus 2 times b. So that here will be an plus a plus b. And here will be an plus 2a plus b. So my left-hand side of my equation, let's sub it in, un plus 2. So I'm subbing in an plus 2a plus b minus 6 un plus 1. So it'll be minus 6 times an plus a plus b. And then plus 9 un, so it'll be 9 times an plus b. Equals 8n plus 12. If I multiply this out now, I'm going to get an minus 6, so it'll be an plus 2a plus b minus 6an minus 6a minus 6b plus 9an plus 9b is equal to 8n plus 12. Gather up my an, so an minus 6an plus 9an, that's going to give me 4an plus 2ab minus 6ab, that's just going to be minus 4ab. Or sorry, plus 2a minus 6a, sorry, is minus 4a. And then b minus 6b plus 9b is going to be plus 4b. Yes. So, 2a minus 6a minus 4, yeah. And then, yeah. So that's going to be equal to 8n plus 12. Now I have an algebraic identity. So 4an has to equal 8n because they both are n. So I equate the coefficients. 4a is equal to 8. Therefore, a is equal to 2. And minus 4a plus 4b is equal to 12. Well, I know a is equal to 2 plus 4b is equal to 12. Minus 8 plus 4b is equal to 12. 4b is going to be equal to 20. B is going to be equal to 5. So I now have here my particular solution for this. So un, and I put a little p on top, really means my particular solution. It's going to be an plus b. So it's going to be 2n plus 5. Right? There's my particular solution. Let's look at my complementary solution. So I now just solve this as a homogeneous equation. So it's un2 minus 6un plus 1 plus 9un equals 0. I now solve this as a homogeneous equation. So write my characteristic equation. So it'd be x squared minus 6x plus 9 equals 0. Two numbers that multiply to get minus 6, but add to get 9. Be x minus 3, x minus 3. I'm going to get x is equal to 3, x is equal to 3. It is a repeated root. So my complementary solution is going to be L times 3 to the n plus m times n times 3 to the n. So remember, if it's a repeated root, it looks like this. So there's my complementary solution. There's my particular solution. So my complete solution is going to be L times 3 to the n plus m times n times 3 to the n plus 2n plus. Right, I'm not done yet. So that's my complete solution. But as you can still see here, I have values for m and l that I need to get rid of. So in order to do that, I now look at my initial values. And my initial values are u0 is equal to 6, and u1 is equal to 16. So u0 is equal to 6. So n is equal to 0 when un is equal to 6. And then u1 is equal to 16. So n is equal to 1 when un is equal to 16. So I have 6 is equal to L times 3 to the power of 0 plus m times 0, 3 to the power of 0 plus 2 times 0 plus 5. It's going to be 6 is equal to L times 1, because anything power 0 is 1, plus 0 plus 0 plus 5. Get L on its own. 6 minus 5 is 1. So L is equal to 1. And if L is equal to 1, let's look at my next solution here. So when n is equal to 1, un is equal to 16, and we know L is equal to 1, so that kind of saved us some time there. So sub it into my general solution here. It's going to be 16 is equal to 1 times 3 power of 1 plus m times 1 times 3 to the power of 1 plus 2 times 1 plus 15. So wherever I have n, I'm putting in 1. That is going to be 16 equals 3 plus 3m plus 2 plus 15 is 17. It's going to be, sorry, it's 5, not 15, 5. Handwriting's terrible. 5. And that's going to be 7. So bring all my numbers. 16 minus 3 minus 7 is going to be 6. So 6 is equal to 3m. M is equal to 2. So therefore, I have my L and M here. I have my L, I have my M. Therefore, my complete solution, UN, is equal to 1 times 3 to the n. I don't need to specify the 1 because anything times 1 is itself, but sure, look. Plus m. Oh, and m is 2, so it'll be 2n times 3 to the n plus 2n plus 15. And I'm not 15, 5. Why do I keep saying 15? It's 5. Right, my handwriting is terrible. Fine. There we go. And that is my general solution to a inhomogeneous difference equation. Now, I'm going to do one more example here. But in this example, I'm going to look at when my inhomogeneous part is a power, like an index equation. So, step 1, let's find my particular solution. So, I'm going to let un equal a times, so my inhomogeneous part is 2 to the n, so it's going to be a 2 to the n. Un plus 1 is going to be a times 2 to the n plus 1. Now, I need everything in terms of 2 to the n. So I'm going to remove that 1 by rewriting this as a times 2 to the n times 2 to the power 1, which would be equal to 2a times 2 to the n. And then un plus 2 is going to be a times, going to be a times 2 to the n plus 2, which is the same as a times 2 to the n times 2 to the 2, which is 4a 2 to the n. Let's sub it in now. So I have 4a 2 to the n minus 2a, 4a times 2 to the n minus 2a 2 to the n minus 6 times a 2 to the n equals 2 to the n. So gather all these up. 4a minus 2a minus 6a. That is gonna give my minus 4a 2 to the n equals 2 to the n. Right? So I can divide by 2 to the n, whatever. So I have 4a is equal to 1 essentially. A is going to be equal to minus a quarter. Therefore, my particular solution is just going to be minus a quarter times 2. There. Right, so we have my particular solution. So let's find my complementary solution. So I need to write down the homogeneous equation. So it's x squared. So the initial, I'm not homogeneous squared. Yeah, my homogeneous equation. So it's un plus 2 minus un plus 1 minus 6 un, and let that equals 0. So I literally just got that from the left-hand side of my equation. My characteristic equation then would be x squared minus x minus 6 equals 0. Two numbers to multiply to get minus 6, but add to get minus 1. It's going to be x minus 3 and x 2. So I'm going to be left with x is equal to 3, x is equal to negative 2. So my complementary solution is just going to be L times 3 to the n plus m times minus 2 to the power of n. Now that I have my complementary solution, So I have my complementary solution, I have my particular solution up here. My complete solution is just going to be L times 3 to the n plus m times minus 2 to the power of n minus a quarter times 2 to the n. Now that I have my complete solution here, I need to find what L and M are. So I'm going to use my initial conditions in the question. So my initial conditions given to me is U0 is equal to 2 and U1 is equal to 3. So U0 is equal to 2. So when n is equal to 0, UN is equal to 2. 2 is equal to L times 3 to the power of 0 plus M times minus 2 to the power of 0 minus a quarter times 2 to the power of 0. I'm left with 2 is equal to anything to the power of 0 is 1. So it'll be L plus M minus a quarter, because minus a quarter times 1 is minus a quarter. Bring the quarter over. 2 plus a quarter is going to be 9 quarters plus L plus M. That is my first one. And then my next one will happen at U1 is equal to 3. So when n is equal to 3, it's going to be 3 is equal to L times 3 to the power of 1 plus M times minus 2 to the power of 1 minus a quarter times 2 to the power of 1. So it's going to be 3 is equal to 3L minus 2M minus quarter times 2 is minus a half. So bring this half over. 3 plus a half is 7. 2 is equal to 3L. Right. So now I have my second simultaneous equation. I now just need to solve them. So I can see here my m's already opposite signs. So I'm going to multiply this by 2. It's going to be 9. So it's going to be 2L 2n is equal to 9, 2. And it's going to be 3L minus 2n is equal to 7, 2. So it's going to be 5L is equal to 9 over 2 plus 7 over 2. 9 over 2 plus 7 over 2, which is 8, isn't it? 8, then 8 divided by 5. So L is 5L is equal to 8. L is going to be equal to 8 over 5. And if L is equal to 8 over 5, so it's going to be L plus M is equal to 9 over 4. It's going to be 8 over 5 plus M is equal to 9 over 4. M is equal to 9 over 4 minus 8 over 5. And M is going to be 13 over 20. So I found what L and M are. Therefore, my full solution to this is, oh no, wait to respond. Right, my full solution to this will be, can you not jam me right now? There we go. Right, therefore, my full solution to this will be UN equals L times 3 to the n, 8 over 5, 3 the n, plus m times minus 2. That'll be 13 over 20 times minus 2. And finally, minus a quarter times 2 the n. That is my full solution there for a inhomogeneous second order difference equation. I hope this video was some help to you guys. And I'll catch you guys later. Actually, no, I won't catch you later. I want to tell you something about inhomogeneous equations, actually. So, this method of solving second order inhomogeneous equations actually will also work for our first order difference equations. So if you want to try it out, right, with some first order difference equations, I do encourage you to try it because it actually still does work. And now I'd like to say, ladies and gentlemen, thank you all for listening, and I hope it was some help to you, and I'll catch you all later. Bye.